Thank you. Hello, everyone. I'm Ahmed Zaki from Large Structure Center for Large Structure Production in Denmark, and I'm here representing monitoring of 3D concrete printing quality through multi-view RGB-D images. The presentation of today will be divided in this section. First, motivation, and after that, the proposed solution will be shown and some examples. And then I will show how we can use the 3D reconstructed model for quality evaluation. And after that, I will show some conclusions and future works. So the process of 3D printed of concrete starts as usual from a design of CAD model of the object, and then generation of the printing trajectory. That depends on the machine that we are using. Mostly gantry system or industrial robots are used. So the focus of research is focused mostly on the material mix or base planning. But the focus of this presentation today, how to evaluate the quality of the printed object at its hardened state, because we are interested in knowing some important errors, especially for layer closure errors and adhesion of first layers. So we are using multi-view RGB-D images to be able to reconstruct the 3D model and then compare it to the CAD model. So we are using a very known 3D stereo depth camera that's quite low cost and also small in size. So it's very effective. So the algorithm starts from considering the 3D printed object as shown here, with diameter almost 1 meter and height of 0.1 meter. We go with the camera around the printed object and try to capture multi-view images that are pairs of color images and depth maps. Here we can see an example of the multi-view images of only color images, because depth map is not so clear for visualization. And then we apply the odometry based stitching algorithm in which we compare a pair of images to find the difference in the pixel positions, so we can estimate the camera movement between two different images, so we can relate the content of the RGB-D images to one common reference frame, so we can integrate all the content of several images to same reference frame, calculating this transformation matrix. Once we apply the integration method, we have the 3D model. Here, starting from one image, here you can see the constructed 3D model. Here, we can see some examples of the technique used. Here on the left side, you can see the color images. And on the right side, you can see the constructed 3D model, and some pattern like layers and also cracks are quite visible. Another example of the used technique, using a simple technique like odometry-based stitching algorithm, allowed us also to reconstruct a big object, almost 2 meters, even if it was not possible to capture all the object in one common image. So here I used 200 consecutive images with quite big overlap between the consecutive images. So here on the right side, we can see the 3D model of this special pillar. So once we constructed the 3D model, we compare it with the CAD model. Here, for this simple object, you can see the CAD model and constructed 3D model. As I told before, we are interested in evaluation of error in according to layer closure and adhesion of first layer. Here you can see that they are overlapping in some parts, but the printed object is quite big in most of the object. So to evaluate the error, we applied Hausdorff distance function that measures the distance between related points in the CAD model and the 3D reconstructed model. And here we can, on the left side, you can see the error or the distance between related points in form of histogram. The red error, the points having the red error have small error, and yellow intermediate error, and according to the visualization, the blue point has the highest error, and the error is measured in meter. And also this way can allow us to find mean value of the error and maximum, so we can be able to plan surface finishing of the object or detect if underfilling or overfilling occurred and where it happened. In this paper, we showed how to use a low-cost stereo depth camera to reconstruct 3D model to be able to evaluate the quality of the 3D concrete, 3D printed concrete objects. And future work, it consists of the use on the installation of the 3D camera on the nozzle of the 3D printer, so we can, instead of applying a manual scanning process, we integrate the scanning process in the program of the printing process. So after the printing itself, we can move around the object and reconstruct the 3D model, and hopefully after that plan also the surface finishing steps. That's all from my side. Thank you.